I'm Grant Geisler, and I'm the mathematician of all mathematicians. I'm going to be showing you some math today with my other colleagues.
I'm not very good at calculus, but I'm going to do my best.
I'm Tucker Smith. We're going to work really hard on this and get
Grant
great
Geisler back here. I'm going to explain the 5 concepts that we're going to go over today. Number 1 being limits, and within the limits we're going to explain it with speed limit and a weight limit. Our other thing is distance and displacement. With our example in this, we're going to do driving and maybe some walking. And also velocity, and we're going to use an example for that by throwing a football, maybe some other stuff, I don't know. Another one of our ideas and concepts is the maximum area, which we will show by fencing. A fencing problem. I don't have actual fencing, I'm sorry. And then our last concept is differentiation, and we'll show that by running and throwing an object and going from velocity or distance to velocity to acceleration.
The first point of calculus we'll be looking at is limits, which is a point or level beyond which something that does not or may not extend or pass. And the examples we'll be using are speed and weights.
Alright, the second point of calculus we'll be covering is distance and displacement. Distance, which is a scalar quantity that refers to how much ground an object has covered during its motion. And displacement is a vector quantity that refers to how far out of place an object is or the object's overall change of position. And we'll be doing driving and walking. That's it, man.
I bet some of you guys are probably wondering what the third concept, velocity, is. Well, let me tell you. Velocity is the speed of something in a given direction.
Maximum area is a region or space allocated for a specific purpose.
The last topic that we're going to talk about is differentiation, and that is to calculate the derivative or differential of a function, as in running.
I'm going to explain our first concept, the limits, first by working on weights. Are you ready? Yeah, maybe. Alright, give me a lift off.
Alright, here we go. You ready?
Yeah. 3, 2, 1.
Oh. You got it, man. Get it! Get it! It's all you, man! It's all you! It's all you! I didn't even touch it, dude. You didn't even touch it. It's all you.
Throw me out some 2.5s.
2.5s?
Yeah.
Alright. I got you, man. I got you, dude.
Alright.
Here we go. Second set. Maximum limit right here. Maximum limit. Alright, you got it.
3, 2, 1.
Oh. Alright, you got it. Come on, man. Get it. Come on, man. Come on. I'm not touching it.
Alright, I'd say that's my limit.
It's your limit, man.
Whoa, man. Whoa.
What's wrong?
Speed limit's 25 miles an hour. Quit running so fast.
My bad.
Where have you been, young man? It's 12 o'clock. You were supposed to be here at 11.
Mom said I could come home at 12.
Well, if Mom said you're supposed to be here at 12, and I said 11, I guess your limit for the curfew didn't really exist.
Yeah, exactly. In your face.
Calculus. Alright, to explain the limit that just happened in the previous curfew example, we're going to draw this. That's a plane. Now, if Mom said to be home at 12, and Dad said to be home at 11, there's a space in between, making it a discontinuity, which means that the limit did not exist.
D&E.
Oh, hey there, I didn't see you. Now we're going to explain the concept of distance and displacement. Dude, what are you doing?
Just playing stay away, man.
No, stay away!
Dude, I have to wait until it's done displacing.
This is Grant Geisler, and I'm going to do distance and displacement. Alright, now I'm going to show you the equation on paper. Alright, I went a total of 0 to 400 feet at approximately 5 miles an hour. Now when we plug in the numbers, it's going to end up to equal 2,000. And then we're going to go over here. I also went a negative, came back and went from 200, 0 at 5x. Plug in the number. This means I want a total of 1,000 feet for our displacement.
1,000 feet.
1,000 feet.
And if you combine the two, all you do, bam, with plus sign and 7 minus, it turns out to be 3,000 feet total distance.
Total distance.
You want to see some velocity?
Man, that was Cooool Calculus. Explaining velocity on paper kind of goes like this. Connor threw the football starting right here, and I caught it right there. As he threw it, the velocity was positive going up, but the acceleration was stopping it going down for negative. And then right here, at approximately this point, the velocity was 0. And then it changed directions, and the velocity became negative, but increased instead of decreased here from the acceleration because it was also negative going down.
Hey man, I need to put up some fencing. Can you help me out there?
Dude, I like 500 feet in here.
Well, what's the maximum area going to be?
I don't know, let's go figure it out.
This is the fencing box we're going to make, and we need to find the maximum area. So first we're going to set up an equation that relates the two through perimeter, which is the amount of fencing we have. But then we need to find the maximum area, so we write down that equation. And then through this, we're going to have to set it up with the finding the single variable for the y. Then we're going to solve that. Then we're going to apply that to the area. Find the derivative. Then we're going to need to solve for x. X is going to be 125 feet. That means we need to solve for y. And y, when we plug it back in the equation,
Do it in your head, Grant.
y equals 125 too. Which means y is going to be 125 feet, and so is x. Dude, Cart, you want some chocolate?
Chocolate? Not in my diet!
This is going to go with differentiation. We're going to start with the displacement, which is the chocolate we threw off it. Negative 16t squared plus 37t plus 3. And the t is going to be the seconds, because as the arc right here shows, that's how the chocolate went. And if you want to find any of the velocity or acceleration, you have to take the derivative of it. So you want to find the velocity of it? Alright, let's take the derivative of it. Now let's find out how fast it was going at a certain time. Let's say 1 second. It was going approximately 5 feet per second.
Wow. Wow.
Wasn't learning about all 5 of those calculus concepts pretty fun? I'll see you next time on the Calculus channel.